Good morning, everyone. So today we're going to go ahead and talk about the logarithmic equations and how to solve them. So logarithmic functions and how to solve them. So let's go ahead and begin. This really isn't that bad, and we'll talk about it real quick after this quick warm-up. So go ahead and pause the video and give these a try. Okay, so hopefully you're able to remember the two identities. Any number to the 0 is 1, and a number raised to a -1 exponent is just the reciprocal. Okay, so this right here, a 5 raised to a -1, that is the reciprocal identity, so it's going to be 1 over 5. So easy peasy, right? Alrighty, so here we have a mixture. Here we got two different things going on. We got 4 to the 0, and we saw this identity is right here. So 4 to the 0 is just 1, and the 2 stays in the denominator. Not that bad. Okay, this one looks a bit confusing, 1 over 3, but the 3 has -1 as an exponent. So it's pretty much the reciprocal. So it's going to be 1 over 1/3. And whenever you have 1 divided by 1/3, that just tells you that it's going to be 3. Okay, a lot of students just find the reciprocal of both, and that gives them just 3 with that including skipping this step. Okay, alrighty, so let's go ahead and begin with today's lesson. Okay, so keep in mind we are on Thursday. Today we only have an exit ticket, but yesterday's form is due today at 5 p.m. Okay, so keep in mind you do have homework, so in that 1 hour break that you have, please use it wisely. Okay, so let's go ahead and begin. I do have a meme for you guys, so El Mundo, and I was fixing the asymptote so you can go ahead and see it. Okay, so if you haven't done so already, please write these down. These are your properties for exponents. So, and I just already had mentioned it, so go ahead and write these down on your notebook. Okay, alrighty, so go ahead and pause the video, write this down, and we can continue. Okay, so what is a logarithmic function? Well, I want you to know that a logarithmic function, sometimes I just call them logs, is the inverse of an exponential function. Okay, so what I want you to know is pretty much if I was to reflect this over the line y equals x, right? Something like that. Y equals x. This is a reflection of what we saw yesterday, the vertical asymptote. I'm sorry, the exponential function. So hopefully you're able to see that these are just inverses of each other. That being said, guys, we are only working with the log function. And that is this blue function that I have graphed for you. And I want you to think about what the domain is. So from our domain, we can see that the farthest left it can go is y equals 0. So it's going to be domain. The farthest left it can go is 0. And the farthest right, well, we can see that this continues this way. Just didn't draw the arrow, is infinity. So keep in mind, this graph does not exist on the left-hand side, okay? So logs cannot be evaluated at negative inputs, negative x's, because there's no graph. There's nothing. Like if you told me what is this graph at -1, I have no idea because there's no graph here. That being said, guys, you do have a vertical asymptote right here. Before I forget, vertical asymptote at x equals 0. So that even clarifies that I can't go any further left than 0. Okay, so let's go ahead and practice finding the domain. So what I want you to know, and I think I should move the slide to the next one, but what I want you to know is pretty much whatever you have here, whatever you have inside this parentheses, you're pretty much going to set it greater than 0, okay? So you get this x minus 3 must be greater than 0 because our function, right? Our function is our parent function showed us that it looked like so. There's nothing to the left, so everything's to the right of 0. So you go ahead and solve for this, 3 plus 3. So x is greater than +3. So my domain, right, my domain must be all the values 3 all the way to the right. So it's 3 to infinity. Okay, and you can think about it as transformations as well. This -3 shifts everything, including the vertical asymptote, 3 units to the right. Okay, Okay, go ahead and pause the video and give these a try. Log 5x plus 10. So x plus 10 must be greater than 0. Therefore, I subtract 10, x is greater than negative 10. Okay, and just by thinking about that, transformation, you have 10 units that were shifted to the left. So our domain should be negative 10 to infinity. Okay. Okay, let's go ahead and try the next one. Same procedure, 3x minus 1 must be greater than 0. I go ahead and add 1. I have 3x is greater than 1. And I can go ahead and solve this with another step of division. So let me write again, 3x greater than 1, divide by 3, x is greater than 1/3. So no matter what they give you guys, you go ahead and factor that out. Okay, so our domain must be 1/3 to infinity. Okay. Alrighty. So what we want to do, since we know these are inverses, we always want to go ahead and find out, can I convert this to an exponential? Because sometimes it might be easier to solve for an x value. If you do, go ahead and do that procedure. Do, right? So what I have here is what I call the Snail method, and it's a nice little trick that helps students out when they still cannot see the connection between a log and an exponential. So go ahead and pause this video and write these notes down on your notebook. Okay. Alrighty, so what I want you to know is if you were to get this base, right? This now becomes the base of your x. So you should go ahead and rewrite this. I should have went ahead and rewrite this. So a is equal to b to the x. So the base of the log became the base of the exponent. So that's how it looks like a little snail. So I got here turbo, no copyright. Yeah, just kidding. Okay, so pretty much this is how you read it. So log base b of a value a is equal to x. It's the same thing as saying a is equal to the base raised to the x. Okay, so this looks pretty weird, but after you do a couple examples, it clicks. Okay, so let's go ahead and convert exponentials, right, to a log function. So keep in mind, I gave you guys this little template right here. So you can pretty much find where everything is and you can go ahead and put it. So this right here is b to the x is equal to a. And I want to convert it to a log. So there's going to be a log, right? A log in the form of b a, right, is equal to x. So all I have to do really is plug it back in and that should work. But keep in mind that is memorization and it tends to not help you as much. So we can see that the base right here is the 2. So wherever I have a b, I'm going to go ahead and put a 2. So it's going to be log base 2. Then I'm going to go ahead and put my value, which I see here is going to be my a, which is going to be my 64, is going to be equal to my x. And I can see that my x is going to be 6. Let me get right here. This is going to be 6. All right. So pretty much this is what a log is telling you. 2 to what exponent gives me 64? That's pretty much what it's saying. 2 to what power gives me 64? And the answer will be the exponent that it needs. That's pretty much the idea of a log. Okay, so go ahead and pause this video. Give the next one a try. If you need to use the template, so do it. But just try your best to learn what it's actually asking you. So I'm going to go ahead and try to do without the template. So I'm going to go ahead and do log, right? Log, and then I'm going to go ahead and get the base, right? The base, which is 10, right? The base, which is 10. And then I'm going to go ahead and get the value, right? 100. And I'm asking myself, 10 to what power gives me 100? And your answer should be 2. That's how you go ahead and use it without the template. So go ahead and pause the video and try it out. Use any method you want to. So, okay, so log, right? Log to the base 8 of 1. Okay, so I have 8. I want to raise it to some power I don't know. That is going to give me 1. So hopefully you remember that any power to 0 gives you 1. Right? And we can go ahead and check our work with our template, and it looks good. Yeah, it looks good. All right. So this was where my student struggled a little bit, but not that bad. Here we have logs to exponentials, and we're going to do the same thing, except now here you can use the snail method. Oops, snail method. So students like this one didn't, student with this did not struggle. They got the 5, and it became the base of the 3. So I have 5 to the 3 is equal to 125. And by now, guys, you should have a couple of these memorized, or you can go ahead and do the algebra. 5 times 5 is 25, times 5 is 125. Let's go ahead and try the next one. So you can pause the video in case you want to try it on your own. So I got 2 to the 6th power gives me 64. And you can go ahead and do the math. You might not know what 2 to the 6th power is, but you might know 2 to the 5th, 32 times 2, 64. Quick math. The next one is 10 raised to the 2nd. It gives me 100. Okay, so overall, these aren't that bad. Okay. I am offering extra credit opportunities. So one simple grade is just to sign up. That will be an easy 100. But I also have some videos on there on the Edpuzzle that will replace your lowest scores. So I strongly encourage that you guys go ahead and give those a try. Okay, I got a meme for us today, and I really enjoy this one. So fresh fade is life, but so is math. So let's see if I can get that haircut one of these days, right? Okay, for the exit ticket, guys, not that bad. All I need you to do is convert from exponent to logarithmic or vice versa. Okay, so go ahead and give that a try, and you just send it to me on a private chat, and I'll grade it for you. Okay. Other than that, guys, this is all I have for you. As always, it was a pleasure. Thank you.